Hello students, welcome. Today let's study about solubility. What is solubility? Let's understand with an example. Okay. First take a beaker with 100 gram of water at 20 degree Celsius. Then take 35.7 gram of sodium chloride, also called common salt, and mix the water and sodium chloride together. Now it becomes saturated solution. It is called a saturated solution because the solution here now cannot dissolve further more amount of sodium chloride at this fixed temperature. Now remember here three things: saturated solution, fixed temperature, 100 gram of water which is an example of solvent, and 35.7 gram of sodium chloride which is an example of solute. Okay, at a fixed temperature the amount of solute, in this case here sodium chloride, that is dissolved in 100 gram of water or solvent to make the saturated solution is called solubility. So in this case solubility of sodium chloride at a fixed temperature, that is 20 degrees Celsius, is now 35.7. Okay, let's take another example as well. Again take 100 gram of water now at 30 degrees Celsius, and take 35.7 gram of sodium chloride, sodium NaCl, and mix it. Now on mixing it forms a solution, but it is not a saturated solution. Because in addition to 35.7 gram of sodium chloride, more sodium chloride can be dissolved here, so it is not a saturated solution. Now add more gram of sodium chloride, that is add total 37 gram of sodium chloride instead of 35.7 gram. Now add 37 gram of sodium chloride with 100 gram of water at 30 degrees Celsius. Now it becomes a saturated solution because at 30 degrees Celsius 100 gram of water can dissolve only 37 gram of sodium chloride. In this case, at this fixed temperature 100 gram of water cannot dissolve more than 37 gram of sodium chloride, so it is a saturated solution. Okay, now in this case 37 gram of sodium chloride dissolved in 100 gram of water at 30 degrees Celsius to make saturated solution. So solubility of sodium chloride at 30 degrees Celsius is now 37 gram, is now 37. All right, here sodium chloride is an example of solute and water is an example of solvent. So the solubility of substance at a fixed temperature is the amount of solute in gram required to form a saturated solution in 100 gram of solvent at that temperature. Different substances have different solubility because they have different physical and chemical properties. The solubility of substances can be calculated by using a formula. The formula is solubility equals amount or weight of solute, that must be in gram, divided by amount or weight of solvent, it must also be in gram multiplied by 100. Okay, let's take some examples of solubility of substance. Here we have already discussed solubility of sodium chloride. Sodium chloride is an example of solute. At 20 degrees Celsius is 35.7, whereas at 30 degrees Celsius it is 37. Alright, let's take another example. Solubility of copper sulfate. It is also a solute. At 20 degrees Celsius it is 20. But solubility of copper sulfate at 30 degrees Celsius is equal to 24. Now what does it mean? It means at 20 degrees Celsius, 20 gram copper sulfate dissolves in 100 gram of water, that is solvent, to make the saturated solution. Alright. But at 30 degrees Celsius, 24 gram of copper sulfate dissolves in 100 gram of water to make the saturated solution. Okay. Now you need to observe one thing here. Look, when the temperature is increased, the solubility is also increased in both cases. So we should understand, increase in temperature increases the solubility and decrease in temperature decreases the solubility. Alright. Okay. And the next thing to remember is solubility does not have any unit. Now there comes the question, why? Why solubility does not have any unit? Look at the formula. Look at it now. At the numerator, we have the quantity, that is mass, and at the denominator is also the mass. Now when it is the ratio of same physical quantity, the unit gets cancelled and it becomes unitless. So solubility is unitless. In short, solubility does not have any unit because it is the ratio of same physical quantity. Alright. Okay, that's all for today.